First, just a little bit about me. So I'm Andrei Butnaru. I'm a product and solution security intern here at Siemens and a student at Bournemouth University, where I'm studying forensic computing and security. So a bit about security in Siemens. Before I got accepted in here, I used to research to find out how it is to work in a big enterprise from a security standpoint. And most of the forums, people were complaining about not being taken seriously, about being a bunch of people business-oriented that didn't really know how to value security. I was quite impressed when I came in Siemens. I found something completely different. So from a security standpoint, all the processes and standards were clearly documented. There were no cutting corners or anything like that, and they were continuously aware of the threat landscape. So as Paul mentioned before, the products we develop are complex. They include multiple databases, microservices, everything from infrastructure to the user interface. We tend to do loads of complicated stuff. Plus, we tend to innovate a lot. So innovation, it's a bad wording right there. It always brings more new problems to the table. Yeah, so. We are constantly looking for things to automate. We are constantly looking for things that we can push away so we can extract the real value from our employees. Because humans are expensive, especially in security. There's a skill shortage, they're really expensive, and the baseline security assessments are quite repetitive, so they can be easily automated. The good thing about automation is that eliminates human error, and in security, usually in the security chain, the weakest link is especially the human. Automation, I think, is kind of the best thing born out of human laziness, so we kind of use that a lot. So a bit on continuous integration pipelines. So they allow you to catch bugs relatively quick, and they offer you loads of transparency. You have visibility into what's happening and enables for greater communication between the team members. So it automates the build process, and basically continuous integration is quality assurance. So you're assuring every time someone pushes code to the repo that everything's fine, everything works as expected. So how do we manage to stay on top of the situation from the security standpoint? So mainly what we do, we push as much of the work we can into the build pipeline. So first we uncover the critical dimensions of our product. So the last product I worked on, the really critical bit was the web application. So we research where automation fits in the continuous integration build pipeline, and we write tests and include them in the build pipeline. By tests, I don't only mean unit tests, but abuse and stress tests as well. All right, so here we have some examples of how we can fit in security into build pipelines. So you've got the usual bit from the build pipeline, and then the really interesting part starts right here, where after we deployed the product, we launch the OWASP ZAP Security Weekly, which is a Docker container especially designed for this kind of job. We start the container, run the baseline scan, we extract the report, and based on what the report is showing, if we have any high alerts, we register a failure. We don't want any of that in our code base, or we create bugs for all the alerts. They might not fail the build pipeline, they might fail the process, but we need to create bugs because multiple alerts chained to each other, they might result into a vulnerability. Vulnerability. So this is your usual application integration like flow, and we want to keep that as simple as possible because we can't afford to wait about half an hour for it to complete, 1 hour or 2 hours. In another example, we could use like the nightly schedule. So nightly we run another set of more detailed security tests, which could take up to like 3-4 hours because no one's working on the code, so we can afford that. It's kind of the same thing pulling the OWASP ZAP, but you can afford to spider all the web application, to look at the URLs more closely and see if you have any sort of information leakage. Run an active scan, get the report, and you have quite the same decision making right there. So these are just some examples. This is actually how we do it on one of our projects. So we've got the usual DevOps checks and sorry, let me just check through. All right, and the security bit and the interesting bit starts over here. So after packaging, we build a Docker image, which gets put into a Claire security test. Claire is I'm going to speak about it a bit more after this slide, is basically assessing the security of a Docker image, so not a container but an image. After that, we upload the backend open source software licenses and we deploy it. After deployment, every time we're going to have the bulk of security testing, because that's what interests us the most. So first we have the centering security standards test. This is mostly a suite of tests that assesses the good practices in Docker containers. By good practices, I mean overall good practices and security good practices. Then a port scan. We want to know what kind of information our application discloses through the ports that are open. A NICTO security test. That's mainly looking at well-known vulnerable URLs like .cgis and all sorts of stuff. And then the OWASP baseline scan, which I mentioned earlier. So we start by looking at, so from the bottom up, we start by looking at the image level checks. So here's the output of Claire. It analyzes all the layers of the Docker image, and then it provides us with a summary of what's happened. And it's quite smart, because if the vulnerabilities are quite isolated and they don't affect that much, you can see that the severity on these ones are medium, they get accepted. So you get to push your code to the repo. They're going to create bugs on this, but it gets pushed. Then we move on to container level checks. Here you can see the output of the suite of tests I mentioned before. You get warnings like AppArmor profile is not enabled. You get passes like ensure SSH is not run within containers. So this, especially this bit, is about security. And you get notes like ensure only needed ports are open on the container. So it's really quite helpful when you come to getting insight on what kind of services and good practices you're respecting on the container level. Then we move on to the network level check. So this is an Nmap scan using a special script that digs into the services it finds and looks if there are any well-known vulnerabilities. For example, this machine has a PostgreSQL service running that is quite vulnerable. So you get all this output when this exact step fails in your build pipeline. And after that, we get the application configuration level checks. Here, the NICTO scan and the OWASP ZAP, they're going to run their tests and notify if they find something. All right, so the benefits of this. Firstly, security is less of a compromise. We all know that usually when we have to embed security in our product, it's either in the form of long passwords. After that, you have two-factor authentication. So you usually have to make a compromise when you're implementing security in the products. This helps a lot. Treat security as a process. Many of the businesses, again, that I've read about, they treat security as a product, which is a mistake. Security is a process. You have to take care of it all the time. You have to treat it as a process. It reduces the time of debugging, because you always see where your application fails. You always get notified by what's happening, and you get notified about the vulnerabilities the developers are introducing in the code, maybe unknowingly. And give the business a proactive stance regarding security and product quality. So as I mentioned, this does not only help with security. Depending on the suite of tests you put in the build pipeline, it can assure the product quality as well. And the save time and resources can be used to add real value, not taking care of processes that take too long, that are repetitive, so you can just sit back and maybe have a beer. So, questions?
How long does it take to run like the initial, the suite tests get run every time, like the Docker scans and stuff like that?
So
how big is the container? The image it scanned? Is it a big application?
So the application in and of itself, it's not too big, but it takes a bit long to get pushed through the build pipeline because I took care of the security and I've kind of put the bulk of security tests only on the application integration level. We don't have nightly builds. That would help a lot. So yeah, I think it takes somewhere around 40 minutes last time I checked.
Need any special frameworks to kind of run this, or is it just all straight integration with Jenkins?
Yeah, you can do that in any, like, we're using GitLab Git Runner, but you can use that in Jenkins, you can use it anywhere. I've got like my GitHub repo after that, and you can get there like the Docker images, you can get all the standards, like the central security standards that are really helpful, not only for Docker images, but for anything really up to like Android devices. So you can integrate that. You can already find Docker images that are specially built, just plugged into your Jenkins build pipeline, and they work. Anything else? Yeah.
What's the difference between the image level scans and the container level scans? Was the images the sort of images that you're dependent on within the
yes, so you spin up the container based on an image that has multiple layers.
Mm-hmm.
So I really recommend looking into Claire because it's really smart and it does the job. So it looks not only on it looks into the layers of the image, and after that the image itself, and sees if it has any vulnerabilities, because you might not have like, it might or might not result in vulnerabilities in the container, but it's good to know them beforehand. And I've taken a look at the overall security status of Docker containers, and you have vulnerabilities popping up every day. Yeah, so it's good to keep an eye open on those.
So you're looking for vulnerabilities not in the application that's been written here, it seems, but in the platform they sit upon.
Yes. Yes.
How do you handle them? All your Docker containers built yourselves from scratch, or are you laying them on something else? And how do you handle their vulnerabilities? How do you have like your own internal marketplace, internal registry of approved images or something?
The images I presented were built by myself. So the team that works on this project, they built their product, their web application Docker image. So these get run alongside and pointed to the web application at different stages in the build pipeline.
But we have a well-known containers basically, and we build the containers also.
Yeah, because that's always been like with Docker, is trying to work out how to have like a. Developers always go, I can just pull this from whatever.
Yeah. And it happens as well with some open source library, right? So you can say, yeah, I'll use that one, but you never know what is the vulnerability of it.
So it's just
We
having
also
a,
had like recent vulnerabilities with Alpine, as I understood, which is probably the most popular Docker.
Yeah.
Where much do you store your images when they're built?
In our private Docker
Your
repo.
own.
Yeah.
So now we use GCR, which does the scanning for you as well. So in the Google UI, it will show you the vulnerabilities, which is, I think, uses Claire behind the scenes as well, which is
Okay,
nice.
that's very cool.
If anyone's using, I don't know if Amazon do it.
I don't
They
think
do
so.
not.
Not at the moment.
Now it's working on, you can get it,
Yeah.
it then pushes it to an SMS.
Yeah, I saw you show that last talk too, which was
Oh,
really
yeah.
And I think that could be quite helpful, because I think setting up Claire is quite a big challenge.
It took me 2 weeks. Yeah, I lost plenty of time on that.
Yeah. I suppose in theory with that process, you could have an image built, it passes, goes, but then a vulnerability is found. Do you ever go back and rescan images?
Yeah, so whenever something is found that is like, it blips a red light, the build is gonna fail. The code.
But if the build passed and then 2 days later they find the vulnerability.
Oh yeah, when you push code, so that's the good thing about continuous integration. The developers are going to push code often, so you're going to know about that whenever it appears. They update their repos, so you're gonna get notified.
Yeah, but if you imagine an application that's really stable, no development, its last build was 6 months ago. Yeah, I guess the question is, would you ever go back and scan an old application?
Yeah, you could do that, but if you're not using it in the context of continuous integration, you're not getting the result as quick. You're gonna have to manually scan that.
Yeah.
Yeah.
I guess if you're aware of the vulnerability anyway, then
Yeah.
So the
I've just been in, I mean, there's a really good approach. I like the whole approach. I've also heard from other people that they have a background process running every week or every night to scan all the images in the repo, even the ones that are not built that week or whatever.
Yeah.
That's good.
Have you Have you found any good techniques to generate the whitelist?
The whitelist, I actually didn't work with the whitelist. That was, I wouldn't know how to answer to that, sorry.
How are you keeping the noise down in the scans?
Keeping the noise down.
Because they can be quite noisy if you have them configured.
Yeah, I'm not really sure. So I did have some problems with the, actually it was quite funny because the Zap container had some vulnerabilities and they would kind of mangle the results because Claire was complaining about Zap, Zap was complaining about something else, but that got solved by someone else because it was way out of my expertise.
Good.
Great.
Cool.
Yeah.